So the first thing we're going to be doing today is factoring polynomials. Now notice something, you're only going to be given ones that you can actually factor, okay? There are a lot of polynomials out there, just like there's a lot of quadratics out there that don't factor. I'm going to show you how to do the ones you can do. First of all, you've got three terms here. Notice that you do have x in each of the terms. That's what our greatest common factor is. So your first step is to factor out an x as the greatest common factor, leave it in front. When you factor out an x, you have x squared minus 2x minus 15. And notice what you have in parentheses here now represents a quadratic, which we know how to factor. All right, so what multiplies to negative 15 adds to negative 2? How about negative 5, positive 3? Bring down your x. X minus 5, x plus 3. All right, that's what you're doing. Three factors. This is a factor, this is a factor, this is a factor. Okay? Let's do another one. Same thing. First, factor out an x here because you have one that you can factor out, and it leaves you with x squared minus x minus 12, which is quadratic. You know how to factor this. What multiplies to negative 12 adds to negative 1, negative 4, positive 3. So x minus 4, x plus 3. All right. The next thing we're going to do is we're going to talk about what it means when you have a polynomial function that is given to you in factored form. This is factored form, okay? So we have a little box that explains this. This is just saying the following are equivalent statements about a real number b and a polynomial, blah, 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 blah. All right. X minus b is a linear factor of the polynomial. Then b is a 0 of the function. Okay? And we know that. That's the same as it was with quadratics. b is also called a root of the polynomial equation p of x is 0, and b is an x-intercept of the graph. Those statements are all exactly the same as they were when we learned about this with quadratics. So when we go down here to the example at the bottom of the page, it says, let's keep that box visible there, what are the zeros of this function? All right? You have this function. So here's the thing. What you're doing is solving x plus 2 times x minus 1 times x minus 3 equals 0. Use your zero product property. If this times this equals 0, then either this is 0, or this is 0. So you have x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Subtract 2, x equals negative 2. Add 1, x equals 1. Add 3, x equals 3. So these are your zeros, which are also known as your x-intercepts. So here's what this means. You have an x-intercept right here, you have an x-intercept right here, and you have an x-intercept right here. All right, those are your x-intercepts. Now, if you were to FOIL these all together, let me ask you, is your x to the third term going to be positive or negative? Positive, positive, positive. It's going to be positive. Your x to the third term is going to be positive. So, x to the third is positive, which means your function is going to look something like this. It's going to be down, up. All right? So this is going down, we know that for sure, and this is going up. But we've got some bumps in here, and it would be really slick if we could figure out what some other points are. Hard to say, but we could try. So what we're going to do is put in some x values. So I'm going to try -1, 0, and 2. Those are my points in between. And see if I can get some more information about how this looks. So if I plug -1 in here, I've got -1 plus 2, -1 minus 1, -1 minus 3, which gives me 1 times -2 times -4, and that gives me positive 8. That is way up here. Maybe right around there. Okay, 0 plus 2, 0 minus 1, 0 minus 3 is 2 times -1 times -3 gives us positive 6. So I've got a point right there. If I go over here to 2, I've got 2 plus 2, 2 minus 1, and 2 minus 3, which is 4, times 1 times -1, which gives me -4. That gives me a little bit to work with, right? So there we go.